Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be looking at how you make quick sketches of the graphs of sine, cosine, and tangent. Now, being able to make a quick sketch of trigonometric functions is very helpful for many types of trig questions at A level. And to make a sketch, surprisingly little needs to be remembered. You do need to know the general shape of the curve. Sine and cos both have the same general shape. You need to know the value of the function at x equals 0. You need to know that sine and cos both have a maximum of +1 and a minimum of -1 on the y-axis. You need to remember that a significant point is reached every 90 degrees. Now, a significant point, that means a maximum point, a minimum point, or an intersection point with the x-axis. Sine and cos both repeat every 360 degrees. They've got a period of 360. And tan repeats every 180 degrees. It's got a period of 180 degrees. Okay, let's look at sine x first of all and go through all of that. So the general shape of the sine curve, you should know, but if you don't, that is the general shape of a sine curve. The value of the function at x equals 0, well, sine of 0 equals 0. If you forget, then just very quickly use your calculator. But sine 0 is 0, which means we can now put in the axes. And the curve starts there at 0, heading upwards from 0. Sine and cos both have a maximum of +1 and -1. That just gives you these top and bottom points on the y-axis, +1 and -1. A significant point is reached every 90 degrees. So this intersection here is at 0. This maximum will be at 90. That intersection will be 180. That minimum will be 270. And we'll get back to where we started again at 360. So you'll have something like that. And then sine and cos repeat every 360 degrees. So that's one complete cycle. It then repeats again, going in both directions. So you'd get something like that, where I've just written down the intersection points of the curve and the x-axis. What about cos x? Well, the general shape of the curve is the same as the general shape of sine x. It also looks like that. What's different is the value of the function at x equals 0. So cos of 0 is equal to 1. So we'll be starting at one of these maximums. And if I draw the axes in, then here the maximum at cos of 0 is at 1. Also got a minimum of -1, so it'll go down to -1 here on the y-axis. Again, a significant point is reached every 90 degrees. So this intersection here will be at 90, the minimum will be 180, the intersection will be 270, and we'll get back to the top again at 360 degrees. Sine and cos both repeat every 360 degrees. They've got a period of 360. So putting in all of the angles, again, just putting in the intersection points on the axes, I would get that. Now, tan x is the odd one out. It does not have the same general shape as sine and cos. Its general shape is like that, where it goes up, and then you get a point of inflection, and it goes up again, and you have asymptotes at either end. It's the same as sine. So the sine of 0 is 0. The tangent of 0 is also 0. What that means is when I draw the axes here, then where x is 0, y is 0. A significant point is reached every 90 degrees. Well, if this is 0, here, this asymptote here will be at 90, and this asymptote here will be at -90. Tan then repeats every 180 degrees. So this shape just keeps on repeating again and again, every 180 degrees. And it still repeats every 360, but it repeats more frequently than that. It repeats every 180 degrees. So just to remind you, to make a sketch of a standard trig function, not much needs to be remembered. You do need to remember the general shape of the curve. You do need to remember the value of the function at x equals 0. And for sine, that's 0, for tan, that's 0, and for cos, it is 1. Sine and cos both have a maximum of +1 and a minimum of -1. In all three cases, you reach a significant point every 90 degrees. Now that either means an intersection point, a maximum, a minimum, or with tan it could be an asymptote. Sine and cos both repeat every 360 degrees. Now tan does as well, but it repeats more frequently than that. It repeats every 180 degrees. Okay, you should have a go at quickly doing 3 of these yourself. So have a go at making a sketch of sine x, cos x, and tan x in the range from x equals -360 degrees to +360 degrees. I'll let you have a go at doing that, pause the video, and come back to me again when you're ready. Okay, let's quickly look at these. So sine x between -360 and +360, you should have something like that. Cos x between -360 and +360, you should have something like that. And tan x between -360 and +360, you should have something like that. It is important that you show the asymptotes, that you do draw them in when you do the graph for tan x. Okay, one more example of how this is used in practice. Find the principal solution of sine x equals 0.5 by using your calculator, and then use your sketch of sine x from -360 to +360 to help you find all the solutions of sine x equals 0.5 in that range from -360 to +360. And do that by using the symmetries in the curve. I'll let you have a go at doing that yourself first, and then I'll explain exactly what I mean to you. So pause the video and come back to me again when you're ready. Okay, let's have a look. So sketch the graph from -360 to +360. Well, we did that just now, and that is what it should look like. Find the principal solution of sine x equals 0.5 using your calculator. Well, if you do inverse sine of 0.5, you get x equals 30 degrees. So x is 30 degrees, sine x is 0.5. That'll be the point here on the graph. 30 degrees on the x-axis, 0.5 on the y-axis. Now we're then asked to use the symmetries in the curve to find the other solutions. But first of all, 0.5 is this height. The other solutions will all be at exactly the same height. So there'll also be these 3 solutions here, here, and here at a height of 0.5 on the y-axis. Now this one here is the next solution that I would find. The distance from 0 to that point is 30 degrees. Therefore, using the symmetry of the curve, this distance from the point to 180 must also be 30. So to find that point, you do 180, take away 30. And that gives you 150 degrees. So the first solution you find using your calculator. The second solution you find using the symmetry of the curve. Once you found the first 2, all the others you can find just by adding or taking away multiples of 360 degrees. So this solution here, for instance, corresponds to this one here. You just do 150, take away 360, and that'll give you -210 degrees. And to find this last solution here, it corresponds to this one. So you do 30, take away 360, and that'll give you the -330 degrees. And there are no other solutions in the range from 360 to -360. So that is the answer. The solutions would be -330, -210, 30 degrees, and 150 degrees. That gets us to the end of the lesson. If you've got the textbook, then turn to page 125 and have a go at exercise 6F. Thank you very much for listening, and cheerio.